So today we're going to talk about the area and perimeter of similar figures. We've been focusing just on area of polygons, but now we're going to look a little closer at how these are related, how area and perimeter are related when we know that figures are similar. So we have one theorem to deal with today. It's Theorem 10.1. It does not have a special name. You just need to know conceptually what the theorem says. It says if the scale factor of two similar figures is A over B, then the ratio of their perimeters is the same as the scale factor, A over B, and the ratio of their areas is A squared over B squared. So let's look at an example to actually put this into practice. The two trapezoids are similar, meaning they're the same shape but different sizes. What is the ratio of the perimeters and areas of the smaller trapezoid to the larger one? Well, we have the side lengths. So we know that the scale factor, or the ratio, is going to be 6 to 9, or 2/3. And we get that from looking at the two sides of our trapezoid, 6 to 9. The perimeter then is going to have the exact same ratio, 2/3, but our area is going to be 2 squared, which is 4, over 3 squared, which is 9. So A squared over B squared. So the ratio of our perimeters is 2/3, and the ratio of our area is 4/9. Now let's look at another example. Two similar polygons have corresponding sides in the ratio of 5 to 7. What is the ratio of their perimeters and area? Well, we know that the ratio of their perimeters is the exact same as the ratio of their sides, 5 to 7. But the ratio of their areas is going to be 5 squared over 7 squared, or 25/49. Now the area, so these are how area and perimeter relate. So let's put this into practice, how this is actually going to help us find area and perimeter. So we know the area of a smaller regular pentagon is about 27.5 square centimeters. What is the best approximation for the area of the larger regular pentagon? So again, we know these are regular pentagons. So we know all their sides are the same. And so we know here, if we look at our two pentagons, our scale factor, our ratio is 4 to 10. Now to find, we're talking about area here, so to find the ratio of their areas, we're going to square them both. So 4 squared over 10 squared, which is 16/100ths, which I'm going to reduce to 4/25ths, because it's easier to work with a smaller number. So we have the ratio of their areas is 4/25ths. Now we can use that to create a proportion. We know the ratio of the smaller area to the bigger area is 4 to 25, and we know the smaller area is 27.5. We don't know the larger area, and that's what A represents, the unknown larger area. So we have this ratio, and in order to solve this proportion, we use cross products. So we get 4A equals 687.5, and dividing by 4, we get the area of the larger pentagon. A best approximation is 171.9 square centimeters. So because we know this fact, we can now find the area of similar figures. Here's another example. The areas of two similar rectangles are 1,875 square feet and 135 square feet. What is the ratio of their perimeters? Well, we know that the ratio of an area is A squared to B squared as compared to the perimeter, which is just A to B. So we need to find A to B, and we know A squared is 1,875 to B squared, which is 135. So to get A to B, we're going to want to square root both the numerator and the denominator. This will give us A over B instead of A squared over B squared. So when we square root both sides of our equation, we get A over B is equal to 43.3 over 11.6. So the ratio of the perimeters of these two rectangles is 43.3 to 11.6. I want you to try these two examples. If you get stuck, go back and look at the previous two examples, but see if you can use what we've learned in an application sense. Alright, so if we look at this first one, the scale factor of two similar polygons is 3 to 4. The area of the larger polygon is 96 square inches. What is the area of the smaller one? Well, we know the scale factor is 3 to 4, so to find the area ratio, we have to square them. So 9 to 16. And now we're going to set up a proportion. The area of the smaller one is represented by A over 96, which is the bigger one. is equal to our ratio, which is 9 to 16. Using cross products, we get 16a equals 864, and dividing by 16, the area of the smaller polygon is going to be 54 square inches. In the second one, the two triangles are similar figures. What is the scale factor and ratio of their perimeter? Well, we're given the area here, and we know that the area is a squared over b squared, or 50 over 98, because that's what we're given. Now, if we reduce both of these fractions to 25/49ths, it'll be easier in the long run to square root. You don't have to, you will still get the right answer, but in my mind, I know I'm going to have to square root these numbers, and I'd rather one square root smaller numbers, and I know the square root of 25 and 49. So when I square root the numerator and denominator, or I square root 25 and I square root 49, I get a over b is 5/7. So the two triangles are similar, and the scale factor of their perimeters is going to be 5 to 7. Now, let's look at this a little more real life, and we'll talk about the scale factor with money. So the scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller cost is $2.50. How much is the larger piece? Now, when we're dealing with 3 to 5 is our scale factor, but when we're dealing with the cost of glass, you pay per square inch per square unit. So we're going to need to deal here with area. So our scale factor is 3 to 5, but we need to find the area ratio, which is going to be 3 squared over 5 squared, or 9/25. Using that, we set up a proportion again. 9 to 25 is $2.50, or 2.5, over x. Cross products gives us 9x equals 62.5, and when we solve for x, we get the larger piece of glass is going to cost $6.94. And that's it. We're going to talk about and do more practice in class. Bring your questions. Have a great night.